Hello, I am welcoming you all to this week's code walkthrough session. I am Bhaskar Banerjee, and in this week we will see some topics like cloning of objects, and then we will move on to a let's say something new kind of programming. I mean, new to most of you because here we will see a flavor of what is popularly known as functional programming uh, in the domain of programming languages or in the domain of programming paradigms. So something that we call functional programming, right? So if you have heard about the language Haskell, right? So this mainly Haskell is quite a famous language for functional programming. So what is this functional programming? We will just see a briefly, and then we will move on to the topics of higher order function and lambdas and stuff like that. Fine. So let's start today's session. So first of all, we will see the topic of cloning. Now, what do we mean by cloning? As the name suggests itself, that it is about basically copying something, right? Cloning means what? You are basically creating a new copy of something. So cloning is copying of objects in Java. Now, why do we need a separate term for such a trivial concept which we have already kind of seen, right? You might have copied your objects uh, previously also in different while writing different codes. So why we are giving it a new name? So we'll see that. But so moving to the coding part, I would ask you to remember this that we have asked you a question while writing the Java 1 uh, package. And so while we are making in the initial, I think week 3, we were writing code3.java program, which was basically the linked list which we created, right? I think it was about the linked list, and I think we were trying to create a linked list of different types of objects, generic objects, and in which I think we were trying to compare between those objects, and we kind of we had overridden the comparable interface method. But anyways, I might be wrong about that. I'm not checking it now. Okay. But anyways, let's anyway check it. So Java 1 code 3. Java 1. If you see here, what was it about? Sort function here. So we were sorting, right? Quick sort. Quick sort of. Yeah, so we have this comparable interface which we created. By the way, so now we have already seen that there are two components. There is a comparable interface, and that interface is already inside Java, right? Which is already has been created as a part of the java.util package. So that comparable is separate. Don't get confused. So this is something we kind of chose. We have chosen the same name so as to give you an idea, so that you feel much more ease while relating this concept with the concept of actual comparable interface of java.util package, right? But this comparable which we have defined here and the comparable that Java's internal util package already contains, they are separate, right? So this is the same name I am using, but if you might ask that, okay, but then how can you write the same name interface here? The reason is it is not public, you see, as now we know access modifier. So here we have not used the public access modifier. It is an interface which is default. What do you mean by default? The default means it is package private. So this interface is basically within the package only. So within the this Java 1 package, right? So it is not accessible, or it is not its existence does not matter outside the Java 1 package. But that java.util interface, comparable interface, that can be imported into any program, and then it can be used to override the compare method and compare to method and then work with it. But anyways, so that comparable and this comparable is separate, but we had kind of wanted to generate similar idea where we have a compare kind of method which is CMP in this case, and we asked you to override this CMP method in one of the classes, which is in this case student class and I think employee class, and accordingly we will have separate sorting criteria for student type object sorting and employee type object sorting. So two different criteria, right? So this is the compare method overriding for employee, and accordingly this is the compare method overriding for students. So two separate implementation. So now we know all these concepts. But what is interesting over here is, so while writing the partition function of the quick short, we asked you one question while doing this session. I asked that what if I write these three lines not as a part of this code only? What I do is, rather than, this is basically swapping, right? These three lines are swapping to array elements. So rather than using a code inline within this function only, I can change it with something called a swap function. So and inside that swap function, I basically pass the two array elements, right? And that swap function will be a separate static function, and that static function within this class will do the swapping operation. So it's just basically copying this code and putting into a function separately so that the code looks more modular. So I asked you, let's try that. I asked you guys to do that and see what's happening. So essentially it seems that it should work properly, but you will see that it doesn't work as we expect it to be. And the reason for that is something which we call, Java uses the technique of call by value and not call by reference. Now that is not something very important for us to understand in details, but I think in any interview or in any, if you are dealing with any Java interview, this is a very fundamental question to ask, that what is call by value and what is call by reference, and why Java uses call by value, right? So what it happens actually is, when you create a swap method separately and pass the array elements within that swap method, then this array I and array j are basically the memory. So let's go to the this whiteboard and let us have a brief introduction to this. Then we will come back to the cloning part, because the concept is quite related. So let's say if I so let's say if I would have passed the array I and array j as two parameters to a function called swap, I define a swap method, and inside that swap method I pass arr I and arr j, right? And this is the calling statement within the partition function, calling statement. And the function definition is something like, let's say, whatever, some static swap. Because it was a static method, I'm not calling it with any static, let's say, void, because it is basically swapping and not doing anything else. So static void swap, right? And then the array, whatever the interface name was, right? I think comparable. So comparable obj1, comparable obj2. Right. And then you start the method, and here you write the three lines of code, that temp equal to array obj1 equal to obj2, obj2 equal to temp. So those three lines. Now if you have done this and this was a separate method, then what could have happened? So let us go to the memory representation of this. So suppose this is my memory, right? And inside memory what happens is, I have this location corresponding to, these two locations are here. One is corresponding to, so arri, it is pointing to this location, and arrj is pointing to this location, right? So this is what it is. These are two memory location within the memory. Now if this is a dynamically created array, then it will be, this memory location will be from heap. If it is a statically created array, then it will be on stack. But whatever, this is the kind of the memory representation. Now what you do is, when you pass these two arri and arrj into these two objects, obj1 and obj2, what it essentially does is, it copies. So what is arri story? See, arri is a pointer basically. So this whole thing is a pointer. It is pointing to this memory location. So that means arri is storing nothing but a memory location. Right, so basically if you write arri, then it is referencing the value within that memory, but the L value of arri, the left value, which is what is the content of arri, is nothing but a pointer, and that pointer stores the memory location value of this memory. Okay, so So when you basically copy the ARR pointer, this pointer corresponding to ARRI within any location, so that will do nothing but copy the reference of that memory address to the new object. So the obj1 in this case will store nothing but the reference. This obj1 will store the address of ARRI. It is not storing the value, rather the address of that location where that element corresponding to ARRI is stored. So now obj1 is also a pointer which is pointing over here, object pointer, and accordingly obj2 is also an object pointer which is pointing to this memory location. Fine. So this is what's happening over here. Now, if that is the case, right? If this is how it is working. Now what happens is you do a swap method here, temp equal to obj1, obj1 equal to obj2, obj2 equal to temp, something like this. So what that will do is obj1 will point to this particular memory location. It will be swapped like you want it to be. So obj1 and 2 will be swapped, and we will get obj2 here and obj1 here. So successful, right? We have done everything. But now the thing is, you now go out of the method and return back over here where the main function is, not main, whatever the function name was, initial caller function, to that location. Now when you reach over there, you see that nothing has changed. So the swap has not happened. So you can see that I am doing everything, but the array has not been sorted. Now why it is so? See, the thing is, this obj1 and obj2 have changed location by doing swapping, but ARRI, ARRJ pointers are still pointing to the same location only. And inside inside the caller method, there is no existence of obj1 and obj2. So this is a very simple but blind mistake. It is very common to understand this, but very easy to kind of miss it from your loop, right? So you might miss it very easily. Oh, let's make a swap method, let's pass the arguments and let's swap it over there. So this is something which we do generally very normally. But since Java uses call by value, what that means is it will copy paste the value present inside the ARR pointer. That is basically the reference value, right? The address value. Now that address value is copied, and then it is a separate object which is basically pointing to that particular address. That's why obj2 and obj1 does not make any changes to ARRI and ARRJ, right? That is to the arrays. It doesn't make any changes. And then whatever change you do inside this method, right? Inside this method, that would happen only inside that method corresponding to the two obj pointers. But one thing will happen for definitely. That is what, if you make some changes inside this value using obj2. So let's say if I make this obj2 to be plus 5. Let's say I write obj2 dot, I have this object, right? So I can use this object to reference the data member value within this memory, right? So let's say there was one dot data, that an integer data member called data. Suppose it was an object corresponding to, so the student, it was a student object, right? Or employee object. So let us assuming it is a student object. I assume that there was one data member which was integer marks. So I can now, inside the swap method, I can use the obj2 pointer to access this memory location, correct? So I can write obj2 dot data, obj2 dot marks, assuming the marks is a public access modifier data member. Suppose, I'm just giving an example, public data member. So I can write obj2 dot marks equal to marks plus 5. Right? So I can do that. So if I make that change, then ARRI will also see that change because it is happening in the same memory location. With which handler it is happening, I am not worried about that. But it is happening in the memory location, therefore inside the main, the caller function also, whoever has called the swap function, inside that caller function also ARRI will be showing the changes. But now in this case we are only swapping, we are not making any changes, right? So try to understand this. We are not making any changes inside any of this memory location. We are just swapping. But the thing is that swap is happening among these two objects, which are nowhere related to the main caller function, right? So that's why you are not changing ARRI and ARRJ. They are at their previous location only. only these two objects are getting changed, and that information will not be reflected. That swap will not be reflected within ARRI, ARRJ, and because of this, whether although you are swapping, this is basically, I mean, nothing is happening over here. It's basically dead lines of code. They don't work. They work, but they don't create any changes as you wish it to be. Right. That's why we are writing the swap method, swap over there only inside as a part of the code itself. But there are ways to actually pass it in the argument and return it, but we don't go into so much difficulty. Just write it in line and it will be solved. But yeah, so what we could have done is after doing the swap, if you would have changed the value, if you would have also swapped the values, right, dot data. So obj2 dot data, obj1 dot data. If you would have swapped it on the basis of dot data, then it would have worked. But if you swap it on the basis of dot data or dot marks, whatever, I'm just forgetting the data member name. What I mean is if we swap the data member individually, then it would work. But if we swap the object location, then it would not work because the object locations are inherently a property of that method only, I mean the swap method. So whatever changes you do, it will be reflected within that method. It will be activated within that method only, and it will happen with respect to the obj1 and obj2 objects. It will not happen with respect to the primary ARR1 and ARRI and ARRJ pointers. Getting the point? So, but we could have changed the values. That is, as I told you, we can increase the marks by 5. Accordingly, we can also swap the values by swapping it. So then those changes will happen. But if you directly swap the objects, temp equal to obj1, obj1 equal to obj2. If you do something like this, obj2 equal to obj1 at the end of the day, obj2 equal to temp, yeah. So these lines of code will not work. Anyway, so why I discuss this thing? Because in Java, therefore, since we are simply copying the value of the address, it is called call by value. But let's say in C++ or C language, if you pass if you pass an array, by default it is passed by reference, right? So what is passed by reference is something again a different point. So what it happens is basically it shares the memory location as well. So your obj changes in obj1 and obj2 will also make the changes inherently shown into the other method. So yeah, so that happens in this C++, but Java's main idea is it is a call by value, and that's why this happens. And yeah, so the main point is if you, while copying objects, we have to be very careful what we are doing. When we copy in Java, coming back to Java, when we actually copy two objects, what are we essentially copying? If I write obj1 equal to obj2, that means you are not copying the contents of obj2 into obj1. What you are essentially doing is you are basically copying the reference or copying the address of the memory location where the data of obj2 is located. So there is a memory location where the data corresponding to obj2, whatever the data members part of obj2 is there. So let name, marks, whatever are the data members corresponding to obj2, they are stored in some memory location, right? So when you copy obj2 into obj1, you are not copying those data member fields into obj1's data member field. Please understand this. What you are essentially doing is you are copying the address of that memory location where obj2's properties are stored. That address is being copied into obj1. So if you copy the address, that essentially means obj1 is also pointing to the same memory location. It is not creating a separate copy of each data member that obj2 has and putting their value inside its own copy. It's not doing that. It's simply copying to the same memory location. So that means now obj2 and obj1, both of them are pointing or referring to the same memory location. So both of them are referring to the same data members. Now if you make any change with respect to any one of the object, it will also be shown on the other object because they are referring to the same memory location. So you are just looking at it from 2 points. So changes done by any one object will obviously be reflected on the other object as well because both of them are looking at the same area. Both of them are pointing to the same data member in memory. Okay, so that is how the Java copying works, and now we will see it in the code that how this is problematic, and sometimes it is also useful, but yeah, and how to deal with it. How to, if I want each data member to be copied separately, then how to do that. Right? So coming back to the coding part. So this is what we call, so let me go to the code at first, starting over here. Oh, this is a Java code 3, right? Yeah. Ah. So these two things we will see a little later, what these two lines mean. So we have here an employee class and two data member. Forget about this birthday as of now. We will add a separate field birthday and we will work with it later. So also I have commented this method liner. Since we have added birthday, there will be a method to initialize that birthday. So it's about that. Forget these things now. Whatever is uncommented, see that. We have two fields in the employee object, name and salary, and some getter and setter method. Okay, fine. That's it. We have just one class and we have created an object of employee type and initialized it with a value. Now what I want is I want to create a new object of employee. So let me just create a new object. Employee E2 equal to new. Let's not new. Yeah, sorry. Employee E2 is there. Now I want to copy the contents of employee E1 into E2, so I can write something like this. But the problem is just now, as I explained, while doing so, what will happen is now if I write E2 dot set, right? What is the method to change the set name, right? So let's see E2 dot set name. E2 dot set name. Initial name was Dhruv, right? So essentially if I want to copy, then that means I've copied. Now I want to change the name so that it reflects in another employee with the same salary. So now I want to change the name to, let's say, George. Okay. So in this case, I just want to change the name so that E2 employee will have George as the name and salary as 21,500. So these two are two separate employees. But this is something I want by copying this thing. The benefit that I get is I don't have to set the salary by copying it, right? So system.out.print, now if I print E1 dot get, and let's print E1 only because I have overwritten the toString method, so anyway it will print both the values. Right? So if I do that, and let's see what happens. I did this. Just a second. I just wanted to show the debug log, but anyways, so let us. Yeah, so as you can see here that now both of them have been changed to George. The Dhruv value which was initially there, I could not retain it. Both of them are changed, and that's why this means that they are pointing to the same memory location as I already discussed about. So this is what we call shallow copy. Okay, so this is nothing but shallow copy. So you are copying to a shallow extent, to somewhat a shallow extent. You are not going into deep, and you are not checking each data member within the object E1, and then you are not copying it. So you are not copying it deeply by going into the methods, the objects, proper data members and copying them one by one. You are not doing something like that. You are just copying the object on a shallow basis, and that basically copies the address, and therefore you are basically pointing to the same memory location, and that's how this happens, right? So that's not something that I want or desire, but we want something that we want to copy it as a separate entity itself, right? So this is where what we can do is we can go through each data element and we can copy them one by one. So that is something that can be done. How to do that? So let's say I create another employee object, employee E3 equal to new employee. But since here I have to pass the data members in the constructor itself, what I can do is suppose now I want to E1 dot get name and E1 dot get salary, And let's say I want to have a salary to be a little bit more than 2000 rupees more. Right? So this is something that I can do. I mean, if you just keep it as even the get salary, the same salary will be copied. So the idea is okay, but I'm just adding 2000 just for a little bit of variability. But anyways, so we have this employee E3, a new employee, which we are creating by calling the constructor. So this is a completely new entity which is getting created by calling the constructor. A new memory location will be created, and within that memory location, I am copying the values of the two data member values of another object which we have earlier. Right? So something like this we are doing. So this is fine. If I do that now, if I write let's say system.out.println and I print the E3, let's say E1 plus, in the second line I print E3 object. Now you will see both of them are, we have not changed the name also, right? So let's say E3 dot set name, and I want the name to be, let's say, Gregory. Okay. Fine. So, by the way, this Gregory Perelman is a very great mathematician. You can check that he recently solved the $1 million problem. Not recently, it has been few years. But anyways, he solved the $1 million problem of Poincare conjecture. So, yeah. So, Gregory Perelman, I have set the name, and system.out.println. Now we are printing the two objects. So, let's see what happens now. Will it change both the things? So, okay, let me just comment this one out so it doesn't create any confusion. Right, so now as you can see that already I have used the set name just like previous case, but now the values are not getting changed it is not getting reflected into the previous object, quite quite obviously because of creation of a new object. But so you get the idea that if we create object in this manner, if we kind of you are copying it itself, right? You are copying over here, but somehow it is not reflecting the changes because the memory location is separate, right? So you can also keep it as same if you feel it. So in that case, the other fields will be same, only the name field can be changed, right? Just like we did it before. So this is what we call deep copy, that once you create the copy, then the entities will be separate and then you can modify them accordingly. And the changes will not be reflected. But the problem with this deep copy idea is if you have multiple fields, if you have lot of fields, and when you write real life program, the fields will not only be like this name, salary, like the fields will be something, let's say a database connection object, let's say some properties, some nested object, it will be very complex. So if you have multiple, let's say a particular object has, let's say 100 fields, so it is very difficult to copy 100 fields one by one. So some fields can be in the constructor, some fields might not be initialized as a part of the constructor object creation, right? Sometimes it happens like some data members are there as a part of an object which might not be initiated as a part of the constructor call. It might be initiated later by some method call, right? By setter methods sometimes. So if you do something, if you have many such attributes like that, so you have to basically copy each of those objects by using the getter method and retrieving that value and copying it individually into the let's say by using the setter method of the new object, right? So I hope you are getting it. So what I need to do is I would need to do E1. So considering this example which we have already done, I need to do E1 dot getter method, this get name, get salary, get whatever, all the getter method, and put it into E3 dot set name, set salary, set whatever, right? So into the setter method. And if I have, let's say, 100 plus such attributes or data members, it will be very difficult because I have to write 100 plus lines of code just to copy two objects. That is not something desirable. So what the Java system provides you is what we call cloning. Right? So this is where cloning comes into action. So if you have cloning, so let me just define another method of employee E4. No, sorry, not method, object. So E4 is a reference. Now I will not use the new keyword or anything. What I will do is I will do E3.clone, and that's it. And only thing is this clone method is a part of the object method. So since I'm using E3.clone, that means clone must be a part of E3, I mean employee class, right? But what happens is clone is actually a part of the object class. Now object class is by default the subclass of, sorry, the superclass of all classes in Java. So obviously employee class will also inherit the clone method within itself, and we can use that method. But the thing is this, first of all, this clone method returns an object type. So in order to use the clone method, we must typecast it to the corresponding type that we want it to be. So convert it into employee. Right. Now you see there is still an error coming, which is, if you check it out, we will see that this clone method is not getting referenced, because it will say that this is a protected method defined inside object class, and it is not not usable by employee. And let us see that at first. The method clone from the type object is not visible. Clone has protected access in object class. Why this is happening is, the point is clone is defined as a protected method. Now since we already know access modifiers now, we know protected methods can only be accessed within the subclass outside the package, right? So now I can only access any method which is defined as protected in the object class within that subclass itself. So within that class itself, I cannot do it outside that class. Correct. So since here I am using e3.clone, this is outside the employee class, right? So this I cannot do that as a part of code 10 class. I cannot write e3.clone because this using clone method using an object outside that class is not allowed. We have seen similar example in the package while discussing package concept. Remember? So we need to use that object within that class itself. So if I have to use the clone method over here, I can only use clone method inside this class. Correct? So how to do it then? What we do is we do something very interesting, and let me just okay, so I will do that later. But what we will do is, first of all, we will write public. Okay, then we will write object clone. Okay. Yeah. So then what we will do is, inside the clone method we will return super.clone. This is something that we will do, and the object, the precise close clone not supported exception. Okay, so this unhandled exception is there. So anyway, so what did we do till now? There is an exception is also there in the definition of clone method. We have not handled that. That's why it is showing error. We will come to that. We know already how to solve, right, this kind of problem, because we have learned exception. But what we did just now, let us discuss that. So we have this. Let me go to the definition of this java.lamp.object. You see this protected object clone. Throws clone not supported exception. You see this is the prototype of the function which we are trying to access. So this is an object in the object class. As I said, it is a protected. It is a protected. It is a protected function, clone function, and that's why it can only be accessed as a part of the subclass. Now, what I am trying to do over here is, I want to change the modifier of clone method to public. So what it will do is, now it is accessible outside the this employee class as well. Now, this is a separate clone method. Try to understand this. This is an overridden part. I am overriding the clone method. Right? I can do that because basically employee is a subclass. So I am overriding the clone method, keeping the signature. Obviously, you have to keep the signature and everything same, right? Now, clone's return value was object public. This clone, right? Yeah. So the return value protected object clone, right? So that's why I am keeping the signature same. I want to return object only. Name same, everything same. I'm changing the body, and there are two things that you can change while defining a method, right? keep this thing in mind. This is also very important. First is your access modifier can be changed while doing overriding, and the exception that is being thrown, that can also be changed while you are doing overriding. Now, when I am saying change, what is the change that we can do? First of all, the access modifier can be made less stricter, cannot be made more stricter. So if the access modifier initially in the primary class was, or in the parent class was uh, protected, as in this case, I can make it less stricter. Less stricter means what is less stricter than protected? That your public is much less stricter than protected, right? Also, your default is less strict. No, default is does not allow outside the package. So yeah, default is more stricter. So basically, public is less stricter. So if you define it as public, then you can reduce the strictness of your access modifier, right? So I am increasing the access area by doing it public. But if I try to do it something else, let's say if I try to do it, let's say like this, then you see this essentially means default, correct? But if I write a default overriding of the clone method, then it will show an error, which it says that clone employee cannot override clone in object attempting to assign weaker access privileges. It was protected. You got the point, right? So this is saying that problem. Also, if I try to do, let's say private, same problem. Again, clone in employee cannot override clone in object attempting to assign weaker access privileges. It was protected. So I cannot do either any of the more stricter type while overriding a method. I can do less stricter like public. This is the error goes away. Please understand this. This is not a concept related to clone. It's clone method only. Any method when you are overriding in Java, the access modifier can also be changed, but that change will only happen, can only be done by reducing the constraint or by making the access more wider. That is by using less stricter access modifier. Okay. So this is one thing. So now since this clone was only a protected method in object, I do not want to, I cannot use it outside, outside this employee class. But then again, I want to use e1.e2.clone that is inside the main method of other class. So what I can do is I can make the overriding of clone method by redefining its access modifier to less stricter type. And now I can use this clone method, employee's clone method, right, to inside any class or inside anything, because it is public at the end of the day. And then what I am essentially doing is I am returning the super.clone. Now forget about this because this is coming for the exception we have not handled. It will be solved soon once we write the throws keyword over here. But as of now, just think that we are returning the actual clone methods, whatever the clone method was doing. So inside the class, employee class, I can access the clone method, right? The object class's original clone method. So here I am using super.clone. So it is going to object class's original clone method and returning the value. So this is just a trick. I want to use the object class's clone method, but I cannot do that because it is protected. So what I do is I override it with a less stricter access modifier. And inside the body of that overridden method, I am not doing anything, let's say inclusion. What I am doing is basically calling the object class's method because I can access it as a part of the employee class. That's what it is all about. Now, we have to just take care of this exception because in the definition it throws clone not supported. I think clone not supported, right? Clone not supported exception. So we have to just mention that with the throws keyword. We know that. Now again, one more thing. I told you that there are two things to keep in mind. While overriding method, we can either change the access modifier or we can change the. We can also change the this exception. If the parent method definition showed any exception throwability, then we can also change that exception. Now, what can I write over here? Again, there must be some rules. Yeah, the rules are that since this is a subtype, because you are overriding it in the subclass, if any exception occurs, it should be subtype of the original exception defined as a part of your main method. Your parent method. So if I have the clone not supported exception defined in the object class's clone method definition, clone not supported exception, I can override the clone method in my class by throwing any exception which is a subtype of clone not supported exception, or I can just write throws clone not supported exception. But I cannot write anything which is super type of clone not supported exception. So in case of access modifier, we will relax the strictness. In case of exception, we can only increase the strictness. Why I am saying increase the strictness? Because it will be a subtype or subclass of the exception class, which is defined as a part of the parent method. So I can write any throws any exception which is a subtype of clone not supported exception. Now as of now I don't know any subtype of clone not supported exception, so I will just keep it as clone not supported exception. So see all the errors have gone now, and now one important thing now consists this should have solved all our problem as you can see over here now. But I wrote something over here which is implements clonable. So what is this thing? So this is a new concept for many of you, and what it is all about is that it is not clonable interface. So let us go to the clonable interface and see what it is all about. So you see this is java.lang, java type is java.lang, and that's the interface clonable. Public interface clonable, and that's it. Now you will ask the question, okay, this is an empty, nothing is there, is just opening and closing. There is no method definition, not definition, no method prototype, no method declaration, nothing is there. So what it is all about, what is happening? Yeah, so these kind of interfaces in Java which does not have even a single method in them and nothing, no method, nothing, no data member. So these kind of interfaces are called marker interfaces. Now what are marker interfaces? As the name suggests, they are used for marking something. Now what are they marking? Some different concepts like in case of cloning, it is clonable interface marks that a particular class might use the clone function of the object class. That is the concept. This is the concept that is getting marked by implementing clonable interface. So if you do not implement clonable interface, then the clone not supported exception will be generated if you are trying to call the clone method without implementing the clonable interface. But then you will see that then clone, if let's say clonable method, the clone method was a part of clonable interface and I am implementing clonable interface and therefore overriding clone method, that was an appropriate story. That's how it has been since till now. But that is not the case. Clone method is anyway part of object class, and this clonable interface is an empty interface. But still we need to implement it because this is an internal working of Java. So it's, the function like clonable where memory is involved, in order to make some safety measures, what we have to do is, Java does some things, and because of that internally we have to basically define any class which might get cloned. The objects of that class might get cloned. Beforehand in the compile time, only we have to do that by implementing the clonable interface as a marker interface which marks the fact that this particular class might use the clone method of the object class. Right? So clonable interface implementation is not to override any method like other interfaces, but just to do a marking of the fact that this employee class can use the object class's clone method. So that's why this clonable interface is a marker interface. So as you can see here, I have mentioned marker interfaces have zero method declaration. Okay, so now I have done all my tasks and now I can use the clone method. So as you see, there are no errors, right? And now if I just change the set name and do the same trick again, let us see what happens. Set name to something, let's say called. Okay, so E4, right? E3, E4. So let us see when the name of E3 and E4 get changed after this. We know that E3 was Gregory Perelman, right? So essentially, if the change is getting reflected, anyways, as you can see over here, yeah. So this Gregory and Carl Sagan are two different names, so it is not getting reflected. So that means again this clone method is essentially creating separate memory location, and it is showing you different result. Also, you can just see it more properly by printing the hash code method of each of them. Now we know all these things, that's why we can use this to confirm a lot of other things in a more concrete way. As you can see, the two hash codes for these two methods are these two objects are different. So you can understand that they are basically separate locations. Okay. So till now we have seen cloning, deep copy, and shallow copy. So shallow copy was not something which we wanted. We went for deep copy. Deep copy might get cumbersome because if you have a lot of data member, then you will be in trouble because you have to write a lot of code. Then we learned about cloning. So how it mitigates the troubles of deep copy? Because see here you are writing one line, the 70 number line. It's just call the clone method. It will clone. Even though you have 1 crore data member as a part of this E3 object, all of them will be copied properly. Okay, and all of them will be copied separately into corresponding separate memory location. So this cloning is also done. Now there is one problem with cloning, and here is what we introduce the reference, this birthday reference. Okay, and let us now uncomment this date class. So what is this date class about? We have just basically added a new reference type object as a new data member of our employee object, that we have day month year inside the date class, and we have to just to update the value. We have not created a constructor, so to say, but we have just created this method to update the value, setter method. So this is nothing but a setter method and toString to print the data. Okay, so then we are adding a date type of data member as a part of our employee class, which is basically the birthday of that employee. Okay, so I am uncommenting all the fields necessary for birthday to work properly, right? Okay, fine. So now all the things related to birthday is done. Now we will see what happens if we do that and repeat the cloning process once again. So nothing, right? As I told you, even if we have hundreds of data members, they will be copied properly. So if that is the case, then now also this should work. So let us do one thing. Let us do the cloning from a new, let us create a new object at first. Over here. Employee. Let me also comment it down, because since we have not created the birthday element of all this class, all this object, we will be showing that birthday not coming, that field is null. I don't want to deal with all of that. So employee E5 equal to new employee, and let's add the two values. The first thing is name, so assign a new name, whatever. So let's keep it as Gregory itself. And the name, and the other thing was, I think, salary, right? Salary. Let's see, 55,000, and birthday. Okay, birthday was, we are calling the constructor, right? So birthday is set over here by the set birthday method. So you have to call the set birthday method with the MMY method. Okay, no problem. So we'll so E5 dot, actually then we might not have needed to comment all that part anyways. So set birthday with DD, let's say 18 04 1999. Fine. So we have this set birthday, right? Okay, then what we can do, we are just creating an object. Now let us do the cloning again. Employee E6 equal to employee E5 dot clone. Okay, so this has been done. Now let us just, for the sake of it, change the name of this employee to something else. E5 was the E6, right? E6 dot set name to, let's say, value. Okay. Now what I want to do is, again I will do the print statement, and let's print E5. Okay, so I'm printing E5 and E6. So in the toString method, I think I have handled printing of the birthday, right? This dot birthday, we have printed it, and as a part of date class also, we have overridden the toString method with day month here so that it gets printed, right? Just okay. So let us now see what happens. So you see that it is copied. Gregory name is changed. Galileo salary is also properly copied. That since the name is not getting reflected both places, everything is working, right? So that means that since the name is not getting reflected, it is created on separate memory location, right? So other fields are copied. These two fields are copied. So no problem. So here is where the problem starts coming. So well, I mean, instead of changing the name, or let's say let us keep the name changed only, E6 dot set name Galileo. Let's change the birthday also. So E6 dot set birthday. Okay. So now what I'm doing is I'm setting the birthday of E6, changing it to, let's say, 5th December. 5th December. Let's say 2002. Right? If I'm doing something like this, now let us see, everything should work, right? Because the same field we are talking about, same concept, different field. Just now, initially we were changing name, now we are changing the birthday. So E6's birthday should be changed, but E5 birthday should be whatever it was earlier, that is basically 18th April 99. So you see over here what's happening. So here the birthday is getting changed also. In the initial case, the birthday is getting changed to the latest one which I have changed. So here the name was not getting changed. See, E6 dot set name, E6 dot set birthday. Both set name and birthday are changed for E6. But that same change for name is not getting reflected in the E5 object. But birthday, for that same change, birthday is getting reflected in the E5 object. So it is getting changed. So what's happening? The same concept, if you have understood the initial part of our session, the discussion, since here we are not copying, I mean, in case of birthday, birthday is nothing but an object. It is not a primitive type. So since it is not a primitive type, you are not copying the data value. What you are copying is the reference or the address. So clone also copies the reference address, right? I mean, when the data members are copied, they will be copied one by one according to the data value. But if the data member itself is an object on its own, then that object will be copied as it is. So copying object as it is just a shallow copy, right? So the clone method is also internally doing a shallow copy for object type, but for primitive type it is okay. For object type it is creating a new object, that is fine. But once the clone method is creating a new object, so what I mean is essentially what the clone method is doing is something like this, that it is creating a new object. So let us say the clone methods internally is, let's say writing some employee, sorry, it's not employee, but I'm just giving an example. Let's say it is creating an employee, new employee E6, and then calling the new method and doing this employee, right? And everything is it is doing, passing, and here it is writing E5 dot get whatever get name. Clone method is not doing by calling get name and all of that. It is doing internally. It has its own working mechanism. But I'm trying to give you I'm trying to generate the similar effect. But essentially it is happening. So it is calling the get name or getter method. Let's say for salary also, E5 dot get salary it is doing, right? So basically you got the two things, and then finally you have the date method to be assigned into it. So how we do that about the date? What it is essentially doing is it is creating a new date type object, right? So I mean, yeah, when it is anyhow creating this E6 new object, the corresponding birthday of E6 will be created, a new object will be created. What the clone method it is doing internally is it is doing E6 dot birthday, right? Birthday equal to E5 dot birthday. So this is what my clone method kind of similar. So basically, essentially the action will be different, but the result will be similar to what I have written on the in the commented area. So it is doing E5 dot birthday equal to 6 dot birthday. So internally this also means you are copying shallow, right? Now this if this birthday was an integer value, then you see E5's birthday and E6 birthday are two separate fields and two integers are copied. So now if I change E5 dot birthday integer value, that will not change E6 dot birthday integer value because both are separately stored on separate memory location. So this does not happen with fields which are primitive type, integer double, right? But if I make this birthday a reference type or an object type, like any normal object or let's say string, then what happens is since it's a memory location, then this E5's birthday and E6 birthday are copying, pointing to the same memory location. So that's where the trouble comes. So then it is not a separate copy, it is essentially the same copy. So coming back to the main part of the code, the trouble we are facing is if the data member is object itself, then clone doesn't work as it is supposed to be. So how to solve this issue? See, the problem was the birthday field was getting copied, I mean normally, right? It was getting copied a shallow copy. So what we can do is we will clone the birthday object also. So kind of we will force the clone method of employee to use a separate clone method for the date class. So we will define clone in case of date also, implements cloneable to mark that okay, this also can be cloned. Then we will override the clone method over here, public object clone, just previous concepts, and return super dot clone. What is this? Clone fine. So now we have defined the clone as a part, clone method inside the date class. But now this clone method is not cloning the birthday in a separate manner, right? It is again just simply calling the object class as clone method. But I somehow want to use this clone as well. So how to do that? So let's delete this line. First, what we want to do is let's go step by step. First thing is that I want to clone all the members normally, but the birthday field I want to clone it by using the clone method of the date class, because that is the only reference type field or object type field in our data members. So let me create a new object of employee, let's say temporary, equal to, I will write the clone method, I will clone the actual method that I am getting. So employee super dot clone. Okay, so I'm cloning it normally, but then what I do is I will use the temp dot birthday equal to, now again I wanted to use clone, so this will be date type, and now I will call the clone method of date class, which will be temp dot clone, sorry, not temp dot clone, temp dot birthday dot clone. Okay, and then what we will do is we will return this updated value. Yeah, so let's return the value 10. Okay, so we are returned. Oh, one thing, sorry, this is yeah, this. So basically we are cloning for this, right? I mean the current object. So because super.clone means what? For the current object, you are calling the clone method of object class. This dot virtual because basically this, once we have done the cloning, so we have now have this object for temporarily temp variable. We have already created a space in the memory for the birthday object corresponding to temporary variable. But the thing is that is the same variable, I mean the same space, just like the one object which is calling this clone method. So we want to separate that. That's why we are using the clone method of clone date class now, and therefore that value should copy the current calling object's copy. Calling object means which object? This object, right? So this object's copy of birthday and clone it and create a separate memory location for 10th birthday and store it over there. So this dot birthday dot clone we are doing, right? And yeah, so then we are returning 10. So I hope this is understood. So now let us, if we do something like this, now let us see what happens. This method will be normal because here only one object is there, so we will override it like previously we did, because all the members are private, primitive type, so that's why we don't have to worry about cloning differently. So yeah, so now let us try the same code once again and let us see what happens. So we want to change the birthday and let us see if the birthday is getting changed still or it is maintained for. So you see now the thing is not getting changed. It was whatever it was earlier, 18th April 99, and the one which we are changing now by set birthday, it is not getting reflected in the other object, but all the other fields are properly. So this salary field is getting copied just like it is supposed to be, and name field is getting changed just like it is supposed to be. Okay, so now as you can see, this is working properly. So this is how you clone in case of deep level cloning, right? Now you might ask the question, what happens? Date class itself also has a reference type object as a data member. So the answer is, again, it is very simple. You have to define the clone method in that class as well, whichever class it is, as a part of data member of date class. And then again you have to modify the date class's clone method itself so as to incorporate the changes and call that class's clone method to clone the object. So this is how Java helps you with cloning, but all of this is still okay because basically you have to write 3 lines of code while overriding the clone method, and that's it. And then you can just directly write this 1-line code to do the cloning. But if you wanted to do that manually by copying each object variable, then you will need a plethora of setter and getter methods, and then you have to write multiple lines of code just for calling the setter and getter method at each level of object, right? So this is how cloning works. If you want to copy objects, then this is the way to do it. Okay, so now let's go to the next part of the discussion for this week, which is basically your functional programming. So what is functional programming? Let me just go over here and discuss a few things. So functional programming is nothing but a programming paradigm in which you give preferences to function. Now when I say preferences, what do I mean by that? That means functions can be passed as argument, functions are treated as object. So functions are themselves their object. Okay, so a function is an object. So functions can be composed. Functions can, we can do composition with function. We can pass a function as an argument within another function. We can copy 2 functions just like we copy objects in cloning we discussed, right? So you can just copy 2 functions and then make changes in one of them in some parts of it. You can pass function as argument, as I said. You can return function. This is something much more difficult to comprehend for new people in functional programming. So you can return a function also. You are getting the point? A method or a function returning another function. So the return type will be a function itself, and that function will be returned into, I mean, since you are returning a value, you will basically use a variable to catch it, right? Now that variable object which is catching the function which is returned by another function, now that is itself also a function, and that can be used to call other function or to operate upon that function, to call, I mean, to call itself. Right, so this is a bit confusing. So basically functional programming means where you can pass functions as arguments, okay, return functions from methods, I mean from methods or functions itself, whatever I call it, right? You can compose functions. Composition means, so you know this mathematical thing, right? G of f of x is something like this. So you can compose function. So all these things. So basically the idea is functions are treated as objects. So functions are treated like objects. Okay. So this is what functional programming is all about. And what we do is, since in functions, sometimes you don't, I mean in functional programming, you don't want, since all of them are functions, sometimes you just want the utility, you just want the functionality to work, and you don't want the name given to each time you are using the function. So what I mean is, so let's say you have to add two numbers, and that add any two given number. So that is a statement, right? Basically add I plus j. Now this is defined as a part of a function, right? But that function is very trivial. You don't need that function again and again. Why do we define a function in a programming language? The idea is because if I want a part of code to be reiterated multiple times according to my use, then I will not write it every time I want to use it. I will define a function and I will just call it whenever I want to use it. I will define it once and use it multiple times. So this is the idea behind defining functions, correct? But let's say just like the opposite way, in a functional programming, since everything is kind of function and it is kind of an object, functions are object. So in that kind of situation, if I want to do a functionality of adding two numbers, then that is also, let's say, defined as a part of a functional definition. But then this function is a very trivial one and I don't want to use it again. So I don't want to give it a name, because whenever you give a name to something, that means you can reference that name to use it again. So you give a class and define a class with a name, that means you can create objects of that class. You can basically use that class name to reference properties of that class again and again, both non-static and static properties. So if I don't want to use a similar line of code again, which is very trivial line of code, but it is at the end of the day function in a functional programming kind of representation. So you don't want to give a name to it because you don't need it again. So in such a situation, we come up with the concept of anonymous function. So function which does not have any name, right? And there is a syntax to define those things. So those anonymous functions are called lambdas. Okay, so since they do not have any name, if I want to do some, let's say in theory, when I need to mention as a functional programming algorithm, if I need to mention what it is all about, if I want to write what is the algorithm of the code that I have written, and that is a functional programming code I am talking about, then each of those functions are called lambda or lambda function, because they do not have any name, so the anonymous functions are called lambdas. Okay, so yeah, so this lambda sign is used to actually refer to those functions, and we write the parameters which goes inside it as a set of parameters, lambda parameters, and then we return result from each of these lambda function as the returning values and all of those things, and we can do multiple lambdas as a composition, right? All these things are there. But anyway, so the point is, this is what we call lambda calculus, as briefly mentioned. I mean, not only this simple thing, there is a lot of things within it, but these rules and this whole domain of theoretical computer science is called lambda calculus. which primarily deals with anonymous functions and functional representation of programming paradigm, which is called functional programming. So your Haskell is as I told, there are many languages, but Haskell is a very good tool, a good language for doing functional programming. He's a very famous software engineer, I forgot his name. He once told, I mean, in 2024 only in one conference, he told famously that I think Microsoft Excel is the most functional programming language, because you see in Excel, those of you who are familiar with Excel, you see you do the sum method, that all those, I mean, you just basically write a method, right? You define or you call a method. So whatever, sum from this row to this row, you pass the rows as argument and you mention the method name. And those methods can be used as a composition. You, let's say, sum of, average of, whatever, you are doing multiple nesting of this function. Then you are passing that function in an equal to and summing that up. So those of you are familiar with auto sum features and using advanced level Excel queries, so they know that what I'm talking about. So basically you deal with similar kind of approaches where you have a function and you deal with them like this, in this manner. You are passing it around and playing with it as functions, right? So kind of Excel kind of generates that kind of functional programming idea. So yeah, so he very jokingly said that Excel is the most functional programming environment in the world, used really by people. Anyways, coming back to a code, that was some interesting fact I wanted to share. So if that is functional programming's primary idea is to work with functions as object, as return types, as argument. So basically if you see functions as object, then basically you can return an object. So you can return a function, you can return a pass objects, therefore you can pass functions as argument into another function, all this stuff you can do. So that is the primary idea of functional programming. But before, why we discuss that and why this lambda topic was discussed, before moving into that, we will discuss another important concept, which is anonymous classes. Now we are coming back to Java only, and we will see how Java helps you making anonymous classes. Now, by the way, why do we need anonymous classes? Because as I said, that there might be a situation where you do not need to use that class once again. Only once you need, but that need is such that you cannot define a method and get away with it. You might need a class only to deal with it, right? Because there can be multiple methods, there can be a state of variable which can be present, but you will use it once, but still you need to use a class only. Your application is such. That's the point. So since you will not be required to use it again later, so you don't want to create a plethora of classes, I mean giving different names, creating class files for each of them doesn't make any class files will anyway be created. What I mean is, so basically you don't want to complicate your code. So you want to have a just one-time usage thing, and because of that you don't want to give any name to that. It's meaningless to give a name to a function, name to a programming entity which you will not use later. So that's where the idea of anonymous classes come. So now we will see that at first. Okay, so how we will actually go through, how we will see this concept is, we have an interface called measurable, and it has three method declarations: measure, is observable, and boost low. So this measurable will deal with primarily with different kind of waves. So now we have created a class called sound wave. Now this can also be a different kind of wave. It can be radio wave. So you can create a new class called radio wave and accordingly override the methods to deal with it. Okay, so we will come to that. Just as of now, just think that we have this sound wave class with some parameters, and we have this measurable interface with three method declaration. Okay, so now let's go to this new class. So we have this class sonometer implements measurable sound wave. So this is the class which is implementing that interface, and it is overriding the method which is given in that interface according to the, since you see where sound wave is given. Why? Because this sonometer is dealing with sound wave kind of measurable type. So measurable is the interface which can deal with any kind of wave type. Now I have taken only one wave type, which is a sound wave, and the method overriding the methods of the measurable interface is done inside a class called sonometer class, which is basically overriding the methods of measurable on the basis of dealing with sound waves. I hope this is understandable, right? So again I'm repeating, sound wave is one such wave. I can also have radio wave, I can also have microwave, I can also have whatever, different kind of waves I can have. And each of these, corresponding to each of these wave, I can override the three methods of measurable depending on different classes. So that is the whole idea. So let's say I want to deal with radio wave, then I will create another class called radio wave, which will be a, let's say, corresponding to sound wave. I have a radio wave class, a separate class. And then I can override the method of the measurable interface on a different class, like in sound wave is done for sonometer is doing it for sound wave. I can have another class, some radio meter or something, and that can do it for radio wave class, right? That can override the methods of measurable on the basis of radio wave class. So I will have class radio meter implements measurable radio wave. Got the point? And then I can define the method body according to the logic of radio wave comparison or whatever, the concept of radio waves. Right? Please don't confuse the fact that I could have done a generic type and then I could have passed the radio wave as a part of sonometer only. No, that cannot be done, because in generic you can only change the data type. You can keep it as general, but you cannot change the method definition, method body. In this case, if I want to handle radio wave, then the method body of measure, method body of is observable, and boost flow will also be different according to the condition of radio wave frequency, radio wave amplitude, whatever, radio wave properties. Right? So in that case, I need a separate class. I need another class radio meter which will implement it and do it in a proper manner. So I hope this is the structure is clear. Now, once the structure is clear, what I want to do now is, we are now going to the main method, right? And we have this sonometer, because since ultimately the methods are overridden in sonometer, so I have to create this sonometer object. And then we have two sound waves, right? One with 8500 frequency, another with 20,000 frequency and corresponding amplitude. Okay. Now we are using the measure method of this sonometer class, which is saying that object 1 dot amplitude, if it is greater than object 2 dot amplitude. What is this name thing? So let me just comment it out as of now. I think I printed it because of some debugging, but let's say, yeah. So obj 1 dot amplitude is greater than obj 2 dot amplitude, so then return 1. So this is like the compare method you guys are familiar with. So similar kind of thing we have done. Is observable for sound wave, you obviously know it is sound frequencies are observable up to 20,000 Hz at the max limit and 20 Hz as the mean limit. So that's what we have seen is observable to be over frequency 20 to 20,000 Hz. And boost low is nothing but we are boosting the lower frequency in a wave. So if the frequency is less than 150, then we are increasing the amplitude 1.5 times. Simple three random of methods to override. So then we are basically using this method normally to basically check if I want to boost the low frequency, if I want to do the boost low on that particular sound wave or not. So if these are the conditions satisfied, right, then I will boost the frequency or I will not do it. So basically ideas, we are defining a few methods, using them, overriding them by these two classes and one interface. No new concept, but now what I want to do is, I want to do it, as I told you, I want to do it for radio wave 2, I want to do it for microwave 2, I want to do it for, let's say, 100 plus waves 2. So in that case, I have to create sonometer is there. So like this sonometer, obviously radio wave class I have to create because that represents the entity. That should anyway be there. Radio wave, microwave, all these small classes I have to create. Like sound wave class, I also need to create those classes. That is obviously required. But I can avoid the creation of these named classes like this. So rather than having this sonometer, micrometer, whatever, radiometer, what I can do is I can create anonymous classes and I can still override all these methods. How to do that? So let us see. So what we will do now here is, let me just comment this line out. Oh. First of all, since I do not have a class name now, I will just call the interface name because that's what I have, measurable. Okay, and measurable in this, I want to do it for sound wave, right? And then create a new object s equal to new measurable. Now you will obviously say that I cannot create a interfacer object, right? So, but see what happens. Since I wrote new measurable, it created a parenthesis after this. So if you kind of did not observe it, let me do it manually. So if I do measure able, then call this just like class definition, then I can open a class just like this. Okay, and then I can close it. I mean, it's just a statement like you define a class, right? So only thing is I am defining the class while creating the instance itself, right? So in inline class creation, something like that. Okay, now how to define this class now? So I will not give any name to this class. I will just copy the contents. Fine. Okay, the copying is not done in proper manner. Oh, this is not part of measurable, right? Oh, yeah, no. Anyway, push flow is part of measurable. Yeah. So we have copied the class, right? What is it all about? Is not abstract and does not override abstract method boost flow object in measurable. Why? Boost flow is okay. So since I have not given the type, so see one more point is since we kind of ignored this angular bracket thing over here, right? But here, I mean, we did not need it to give in case of collection, but here we need to provide the type so that it understands because there is no name for the class, so we have to give the type. So sound wave. Actually, if you do not give in some ID, it might work. You might check that out. I hope it shouldn't make any difference, but still, it is better to give. So now see, this is a new kind of definition of class where we are defining it a kind of inline fashion. Okay. Now this S will be used to, this S will be used to refer to the object. So you see, this is not giving any error. This will work properly. Right? So this is, but still you might say that okay, this is fine, then we do not need to use this class. That's okay. This still works properly, right? But then again, I still have this S name, right? This S is a name to reference, like here I am using reference. So multiple times I am using. But I told you that if I want to use it only once, then this anonymous thing helps us more. Yeah, so you are writing that this kind of reduce the complexity or cumbersomeness of the defining multiple classes like personometer for radiometer and for everything else. You can write it as a part of the main method itself in inline classes. But still we are defining, I mean, we are giving it a name, right? In terms of reference, maybe not in terms of class name, right? But we are still having a name to reference it later also. We are not using that one-time use idea. But if you just keep that aside as of now, then this is a new way to define classes and this is a new way to work in Java. So if you see a code similar to like this, similar to this in any code base or in any book or in any place, don't get confused about what it is all about. It is nothing but a class which is getting defined the time it is getting instantiated. Okay, fine. So this is kind of done. Now let's move to the next part and coming to answer the question of if I use it one time, then what will happen? So let's say I have a method, a static method, Yeah. So we have what we want to do now is, let's say we create a let's say we create a method. Yeah, here only we create a new method. Name yeah. So inside this class, let's say we have another method called public static void. And what I want to do now is, let's say we had this boost low. So let's do some low enhancer. Some method low enhancer. Okay. So what I will come to the point which I'm trying to make over here. So let's say we have the sound wave object 1, two objects, two sound waves it is taking. So S1, comma sound wave S2, right? And then what it is trying to do is, it will measure the sound waves, and it will also measure the frequency, and if the all the conditions satisfy, then it will increase the amplitude. So what I want to say is, it is basically doing that boost low kind of logic only, same thing, not much different, same thing, but I'm kind of redefining the boost low method as a part of this new code, as a part of this new function. Only thing is, this low enhancer, since I am defining it as a separate method, what this will ensure is, it is not a part of measurable, and therefore what I will try to do with it is, I will try to pass the functionality within low enhancer. Now what do I mean by pass the functionality within low enhancer? So the thing is, I want to pass two. So here inside low enhancer I have used two sound wave as the object, but let us say that I want to define it in such a manner that this low enhancer method can accept any kind of waves, right? Any kind of waves it can accept, and it will accept one measurable type object. So measurable type object means what? Measurable type objects means sonometer, radiometer, as I told you guys, right? So any one of the meter it will accept. Meter means this basically measurable type. Any class which has implemented measurable interface. So those classes will have already overridden those methods according to the particular kind of wave it is dealing with, whether it is sound wave or whether it is radio wave. According to that logic, it has implemented overridden the method of the measurable class. Measurable interface, right? So I will, as a part of this low enhancer method, what I want to do is, I will accept any two waves. That can be sound wave, that can be radio wave. So it can be radio wave R1, radio wave R2. It can be sound wave S1, sound wave S2. It can be microwave M1, microwave M2. Whatever. So two objects of that particular type of wave it will accept, and it will also accept third parameter, which is basically a type of the class object which has implemented those methods corresponding to that particular wave type. So that will be what? If I want to accept it by giving a common reference type, then that will be measurable type reference, right? Because all these classes corresponding to radio wave, microwave, and all these things, which is basically radiometer, micrometer, sonometer, all those classes will implement the measurable class. That is for measurable interface. That is for sure. So that's why I will write here measurable. Okay, so measurable. Now in this case I am doing it with sound wave, so I am just giving you an example of this sound wave only, but you can also make it generic. That is your task to do. I mean, I am not discussing that part because that is not related to here, but the idea is I want to make it generic, but here I am taking just an example for sound wave only. So therefore I will write here sound wave, but you can also just generalize it by keeping measurable. Generic is anyway there. You can have a functional generic behavior, like, so I hope you got it. So what I mean is, you can have something like this: T void low enhancer. In measurable you can write T type and put an object O, right? And over here you will write T S2. I mean, I shouldn't have shown you guys. These things should be, I mean, you guys should try all these kind of things, right? Which comes to your mind if you want to put a functionality, you want to make a more generic behavior. So try all this kind of stuff, then your programming will be good. So yeah, so this is how you can make the whole thing generic. But then you have to change some other parts of the code as well while you are defining. I just little changes. But the main idea is this. But this is what we are trying to do. In this case, we can pass any kind of radiometer, sonometer, whatever type as a measurable type, and accordingly we can pass radio wave, sound wave, as a part of the wave type. So we want to extract such a feature, but I will take the example of sound wave only since I have not defined other classes as of now. So just change all these things. Okay, so yeah, so this is done. This is what I want to do, right? Now, since this measurable, so what will again stating what I want to do over here is I want to accept a measurable type object and use the method defined inside that particular class to operate upon this sound wave S1 and sound wave S2. Right? It is okay to do that, right? I can. So this is something new. We are basically accepting a measurable object and then call the method of that object, which is basically the object that which are basically the method which will deal with the sound waves, and then I will basically do the task which kind of boost frequency. Boost flow was doing same task. So if O dot same methods I'm using measure. Let's say S1, S2 equal to 1 and then S2 dot frequency. Let's say I want to keep it as if it is less than S1 dot frequency. Right? So if S2 and S1 I am comparing, if the frequency of S2 is less and the measure condition of S1 and S2, basically the amplitude, which is based upon the amplitude condition checking, so both are 1. The amplitude of 1 is greater than amplitude of 2 and the frequency of 2 is lesser than frequency of 1. In such a situation, it is randomly I'm adding a condition to display the concept. So in such a condition, I want to amplify the amplitude S2 dot amplitude equal to 2, into equal to 2, something like this, right? Yeah, so the main part is we are accepting a measurable type object and then using that object calling the methods which I already have, right? And then using it to work upon the sound wave object. So something like this I want to have. So now you see what we can do now is we can also remove this, just a second. In this class itself, anonymous class itself, we can remove this S, right? Because now we are not passing this S or anything. So what we can do is we can simply write that low enhancer, right? Low enhancer object W1, W2, and this is it. See, here only where I would have shown what it was normally, how it should have looked. So I have this, I must pass over here W1, W2, 2 sound waves are gone, and in this place I must pass an object of measurable type. So what I am doing is, I will just delete this part. This is where the class starts, so I just pass it. Just at the end, close the low enhancer method and end the statement. This is not required. Yeah. So you see now, what we are doing now is we are simply passing a class as an argument, and now it is completely anonymous, right? Because since now you are passing as an argument, you are using it once. That's why I told you we will come to the use once philosophy in this way. So when we are passing a class as an argument, complete class, not an object. First time we are defining the class completely. Basically we are passing an object only. Internally it is an object, but that object is defined in line along with the class definition. Right? So the main thing is we are passing a newly defined anonymous class in the low enhancer method. So this paradigm of programming is very common and you guys should be familiar with this. because in many cases this kind of usage happens. So sometimes what happens is this is primarily used a lot in let's say your event driven programming, where you are basically creating a GUI and you have these buttons, right? Java, when we will learn a little bit that later on, that how to have GUI interfaces. So you can create GUI by programming by using different classes. So let's say just by simply writing one Java line, importing a particular package and using some methods in that package, you can create a GUI interface with buttons and text boxes and stuff like that. That's not very difficult to do. It's just one functionality. There is one package which can deal with stuff like that. You have to import that and you can write 2-3 lines of code to generate such a GUI. Now once that is generated, let's say these buttons are there on the GUI, and GUI you have this, but you want to program those buttons. How do you want to program it? So let's say if someone do a right click on that button, what will happen? If you hover over the button, what will happen? So these are called actions. So if you do some action on the button, maybe right click, maybe left click, maybe hovering over it, something will happen, some task will happen. Maybe when you hover over it, the button will change its color. Maybe when you do right click, it will do something. So how to program that? So in the Java code, where you will internally program the actions and the steps that need to be taken by that button when that action on that button happens, those kind of program actually will deal with lot of this kind of let's say programming constructs, where so in case of low enhancer method, you will have this on action method. So on click action, on right click action, on left click action. So you have this action handler or action listeners, where this method will accept a particular class or object as one of the parameters, which will deal with the action that has to be taken when something happens, right? Now, so let's say, let me just again tell the example again, you will feel it more relatable now. So what I say is, I told you 3 kinds of action, right? Right click, left click, and hovering over the button. Now you have this button handler, some method is there, button handler, which accepts the button handler, which money, a button handler, in the bracket you pass W1. Suppose W1 is the object corresponding to the button class. So W1 means the button class object that represents that particular button. So you pass that W1 button as one of the parameter into the button handler function, which is corresponding to the low enhancer function in this case. So just assume in case of low enhancer, you have this button handler function, and button handler accepts this W1, which is a button type object. And then as a second argument, it accepts a class, and that class has 3 methods, and these 3 methods are corresponding to right click. On right click, what should be done? On left click, what should be done? On hovering over the on hovering over the button, what should be done? These 3 methods are being passed. So you cannot do it only one method, do it with one method, right? So you need 3 methods for 3 actions. So you pass it all together as a class, as a parameter within the button handler function, and the button handler internally will accept that class into an object. Like here we are accepting this class into measurable O. So button handler function will internally, in the definition of button handler, you will accept this class as a part of into an object like this, and then you will use this O method of the button handler function to access these 3 methods, which is basically right click, left click, and hover over, right? And you can accordingly do the logic and do what you want to do, how to handle the situation. So these kind of graphics programming, UI design, like event-driven programming uses this kind of stuff a lot. So please be familiar with this anonymous class kind of programming constructs. Okay. So now we have learned anonymous class, and this is truly use one's philosophy, because you are basically passing the class within the main method, and since you do not have any way to refer to this class once again, so here you do not have the existence of that class. So that's why see these are showing error, s.measure, s.is observable, because now I have passed it as a part of low enhancer and there is no s or no way to refer to that class once again. So these are showing error. So let me delete all this. These are not required now. Okay. So now this is done. But now let's come to the idea of, as I told you, that we have in functional programming, all we want to do is pass functions as argument, functions as return type, functions and object, something like this. Now you see we kind of are quite close to a similar approach. Here we are not passing function, but we are passing classes as object. I mean not object, the classes into function. We are kind of also we can do returning and all this kind of stuff. So this can be done. So now a new idea I will introduce, which is called functional interface. So now we come to a new idea which we call functional interface. Now what is functional interface? Functional interface is nothing but an interface with a single method. Marker interface was what? Clonable we did, right? Implements clonable. Clonable was an interface with a zero method. But this functional interfaces will be interfaces with one method. Marker interfaces will be interfaces with zero method. So only if one method is there inside the interface, then mostly it is, we annotate it as a functional interface. So let's make our measurable as a functional interface, and what we want to do now is, let's say we have this let's keep the measure method only, okay? Let's delete all other things. So in the interface I go and let's say I comment these two things out. So we have this measurability measure T0 and T0. Okay. So we have commented the other methods out, and now what I do is, just a second. So now what I do is, first of all, delete these two parts. Right? And here I am doing the measure method only. See? So here I am using only the measure method. I am not using the other two methods. So it should work properly. No problem. Yeah. So see, the code is okay. I have deleted the other two method and now it will work fine. But the thing is, now we will try to reduce some redundant information. What do we mean by redundant information? So you have this low enhancer W1, W2, new measurable sound wave, all this thing, right? So you see that whenever I am writing new measurable sound wave and all this thing, low enhancer method definition, it tells that okay, whatever I am accepting in the third argument, that is nothing but a measurable type object. Right? It cannot be anything else. If you give anything else, then it will be error. So it will be measurable type object. So while calling the low enhancer, do I still again need to mention this measurable and all this stuff? So Java said, okay, I understand that you have this measurable object defined as a part of the program declaration, function declaration. So you no need to measure it again. So I understand that you want to create a measurable, you want to pass a measurable type object. So I will delete all this. Okay. Now, second thing that comes is public int measure. Now, since again we are passing an object over here, ultimately it is an object, but we are passing a measurable type object. So measurable is only one method, which is measure. Now, if you are not directly passing an object like objj and closing the parenthesis, like if you are not doing something like this, where obj is already a measurable object, and basically you are not doing this, rather you are trying to define the class inline, like anonymous class we just did. So if you want to do that, so then that means you will override the measure method, and there is only one method inside the measurable interface. So Java already understands, since measurable has only one method, so if you want to define an inline anonymous declaration of the class, then that would mean that whatever you are writing, that is nothing but overriding the measure method body. So you do not need to mention this overriding part as well, because I understand it is anyway measure method, because there are no other methods. This is the reason we call that functional interface must have only one method, otherwise it will not work. Otherwise it is not regarded as a functional interface, and it will be regarded as an anonymous class when you are basically passing it over here. So this also I delete. Right? Okay. Now we are accepting this sound wave obj1, obj2. Again, this is understandable from the declaration of the function. So I delete the object type. Right? Okay, so that is also done. Then what we need to do? So this we are passing two parameters. It is needed that we are passing two values. Okay. And then all we have to do is add one arrow. This is an additional syntax. So we will just add one arrow. Okay. So one arrow, one straight, one your dash followed by angular bracket, right angular bracket. So that is nothing but an arrow. We have added that. And then the method body is obviously it will be there. Okay. And then what we are doing is this is the low enhancer getting closed, so we don't need this part. Okay, and then the low enhancer method is getting closed. Yeah. So you see, this is what we call a lambda. Now you see what is there. You see, is there anything left of a class? See, previously also it was a class. I did not do anything. The class was working fine. Even if you go back to the previous, I mean, you can just rewind back and check. It was a class and it was working with only one method definition. So, new measurable sound wave in the angular bracket, open the constructor, open the class definition with a curly brace, write the full method, the prototype, right? Your what is the name? This measure, right? Huh? So measure method prototype, write that, open curly braces, then write the definition of the measure method. Everything was fine. If you go back to the previous case, it will work as it is. But then that is redundant information. I mean, it is already understandable as long as it is a functional interface. That means as long as it has only one method in it, measurable, then it is understandable you are overriding the measure method only. So you can delete everything else by the definition only. Of this function, Java will understand that what you want to do. What you are basically doing is overriding that function. So you delete everything else and this is what you reach. Right? That was also correct code if you go back, and this is also correct code, but it is much more concise, much more precise, I would say, not concise, it is much more precise. So it is very simple, very short and beautiful. So this is what we call lambda. Now you see this is kind of a function only. You are basically having this function definition, the function body, and this is the function parameter. So this looks like you are basically passing a function as an argument. So that is why these are quite relevant, and this is what we call lambda. As we call in functional programming, we call anonymous functions as lambda. So do we have a name for this function? No, right? I mean, yeah, it is basically the measure function being overridden and we are deleting the name because it is known to the compiler. That is fine. Those things are internal working. But for a lay person who is looking at it, it looks like a function which has no name and you are basically passing the function as an argument. The only thing new over here is that arrow. Everything else looks like a function. So this is an anonymous, nameless function passed as an argument into another function. That is what functional programming talks about, right? So internally we are not passing a function because Java doesn't have that kind of mechanism to pass functions as object. Internally we are passing an object, and that object is nothing but a class. But that class is an anonymous class. And that class is what? That class is implementing an interface. So you see, we go back to the week 3 idea, an interface implemented by a class. Only new idea is now the class is anonymous, and then you are passing that class. So internally this is nothing but passing a class or passing an object, but actually it looks like you are passing a function, and that's why we call this as lambda expressions. Okay, so these are lambdas, and yeah, so lambdas are basically created by implementing a functional interface. A functional interface must have only one method. Right, so we have this low enhancer and it will work like this. Now you see that if I would have had that generic definition, any measurable type of lambda can be passed over here. Right? I can write anything over here. I don't have to bother about anything else. I mean, I can write any definition over here without bothering about any class or anything. See, the beauty of this, the power of this thing is, I don't have to define class. I don't have to bother about nothing. Just put a line. I mean, whatever you want to do in this O, I mean, by using this O method, O object, whatever you want to do within this method body, you use that functionality. Use that functionality that you want to generate, right? Just define that functionality over here. So you are basically defining a function as a part of argument, and that functionality will be used within it. Without defining any class, without defining any function name, you are able to extract this kind of feature. That's why lambdas are called anonymous function. Okay, so now since this is clear, now you can execute it and check anyways. I've not printed anything, right? Sorry, let me just print it out. So what were we doing in the enhance? Amplitude was getting multiplied by 2, right? So let us take the amplitude of W2. W2 dot amplitude. So what was W2's amplitude? 3, right? So let us see what it becomes. So it is kept at 3 only because maybe our condition is not satisfying. The condition was what? S1, S2 should be 1. 1 means W1 should be greater than W2. Is it so? Amplitude, yeah, W1 was greater, and S2's frequency should be less than S1, right? So yeah, so this condition is not satisfied, right? So let me reduce the value and let us see what happens here. So now you see the value is double to 6, right? So you see this is working properly. Okay, so what we did is we created a measurable interface. With that interface, we kind of defined this measurable interface can take any lambda, right? So looking at it from a fresh perspective, you now know the internal working of lambdas. But let's say operational perspective, you don't have to understand the internals. If you want to have a functionality being passed as an argument, all you have to do is define a interface and have that functionality name as a part of the interface method, and that is a functional interface. So basically you define an interface measurable, put a method name in it, and that's it. And in the accepting function, write that as an argument, right? Accepting, I mean, formal parameter, and then you, whatever you want to pass as a lambda, you can pass it in it. Fine. So we have now done the introduction to lambda part also. Now we will come to a new concept which is called stream. Now inside stream we will use lambda a lot of times, and that time I will not discuss in so much detail. We will just use it as it is, and you have to understand. So let me just randomly go to a particular. So let's say this definition. Yeah. So let's say this map. This map is explode, right? Something. So you see this arrow is there. That means this is a lambda. So what is happening over here? This is basically calling an explode method on S object. Whatever S is, we will discuss that. So on the S object, it is calling the explode method on every S object, right? Something like this. But how is it being accepted by map interface? So if you go to the, sorry, not interface, map method. So if you go to the map method definition, you will see that it will accept a particular interface, functional interface type. So you see this stream map function super extends our mapper. So a big thing is there like this, right? So this function, and then we have generic two generic parameters, and then our object name. So what is this function type? So let us go to the function type and see what this is all about. So you see this function type, right? I want to go to this function type. See what it's shown. Functional interface, public interface, function FTR. And it will have only one method, this R apply. Okay. So you can store this, you can use this method to basically store the values, store the lambdas as a part of that object, that function object, right? So map has this function object mapper over here. Mapper as the object, and inside this mapper object I can store this lambda. Okay, this complete lambda which we talked about. And how it is storing? Because this is nothing but a overriding of that particular method inside the anonymous class internally, right? Okay. Fine. So now coming to this new idea of what are streams. So let's start it. So Streams are nothing but, let's say, what we do is, so we have this collection types, right? We have learned about these collections, and sometimes we want to do a lot of tasks on these collection types. I mean, whatever data is being stored on these collection types, what we want to do is we want to apply multiple transformations on the data stored in them multiple times. So basically, we are for each element stored inside a list, you want to apply this function. Then again, on the newly generated value, again you want to do something. Then on those values, you want to apply some condition. So there will be a lot of function calls. There will be a lot of if-else statement, right, which you have to do in order to do that. So since we are very, I mean, a lot of times, quite normally, we are, and quite a times what we do is we operate upon the content stored inside this collection types by using different function, by using different transformation, by using different condition. Because of this was a very prevalently used, let's say, actions on collections data. We have Java people have come up with this streams idea. Now this is not only local to the collection type of, let's say, it is local to collection concept. You can actually generalize the stream concept, but primarily the idea was to actually have a way to operate upon this collection data in a more, let's say, less cumbersome manner. Okay, where you don't have to write so many lines of code in order to do something which is you are doing very often, which means that if you are doing something very often, a lot of times, then that should be done in a very elegant way, so that you don't have to repeat similar kind of code a lot of times, right? So basically, to remove the cumbersomeness or to have a better, elegant way of working on collections, we came up with this idea of streams. But again, stating that streams are independent concept. I mean, when seen with respect to collections, right? But it is very much useful when you are basically dealing with collection. So how it is useful? What we will do here is we will convert a particular collection into a stream. Now, what is that stream? Now, imagine this stream as nothing but or whatever is content in whatever is there inside each of this collection. You are converting them into a stream of or a flow of data, right? And then on those data, you can apply a particular transformation or apply a particular condition on each of those data very easily, because now you are not iterating one by one, just like using iterators, or now you are not writing a for loop to iterate over them. So you have a stream of flow of all the contents present inside the collection, and on that flow you are applying the changes, like assembly line. You guys are familiar with the assembly line used in factories and manufacturing hubs, right? So what they do, there are multiple people or multiple robots, and there is a belt on which some whatever that company is producing, manufacturing that item is coming, and some person is basically, there are multiple people are there, and they are basically operating upon that in parallel. So on each of the item which is coming on the assembly line, I mean, we don't have to iterate through them separately, or the people don't have to do anything. It is just like a stream of flow which is coming on the belt on the assembly line, and people are very fastly working upon it one after the other, right? So that transformation or that change is being brought upon each of the item on the assembly line very fast. So it is similar kind of analogy you can think. It is a stream of data item which is stored inside the collection, and then on each of these data item you can apply the wanted transformation or condition, right? Okay, so even if we do streams without collection, in such a situation, a stream is nothing but a flow of data. Now, what data that we can mention while we create the stream? So we can maybe mention that create me a stream of integer. Then a stream of integer value will be created. Create me a stream of string values. So if you give the appropriate way to create the strings, then it will create a string of it will create a stream of string values, right? And then upon that you can work. So this is kind of this you can do. There are some other features as well that streams are very efficient in working, because first thing is you can work upon them parallelly. So now we have not yet covered the concept of threading and parallel execution, but once you learn parallel execution, you will understand that all the collections are not thread safe. So what that means is you might have a linked list, not linked list, let's keep it as simple now. So let's say you have a collection in which you have some data, and let's say you have two different execution units running on them. So what is the execution unit? Because these are basically, let's say, two separate executors where execution is happening on the same collection type. So basically, two person is so the collection data is being operated upon by two different, let's say, at two different points. So both of this execution is happening on the collection data simultaneously. So that is done by, let's say, two threads. So two threads are operating on the same collection simultaneously. So in such a situation, one thread might change something which is related to the second thread, and therefore they might get into trouble. And therefore, many of the collection do not allow multiple threads to be parallelly working upon them at the same time. Okay. So but some collections allow that. Some collection won't allow that. So these things are there, but in case of a stream, you can do a parallel computation. So basically, you have a collection. From that collection, you made a stream out of it, as I told you. So once you made a stream out of it, you can again make a parallel stream. And once you made a parallel stream, you can have parallel execution on these two streams. Okay, so those things are there. We will come back to these concepts later once we learn parallelism. Other than that, another thing is, as the lazy execution explained by Madhavan sir in the lecture, that streams can be done in a lazy execution kind of manner. So you can proceed without even completing generation of the complete stream. You can proceed to the next level. So please refer the lecture for that. Okay, so now let us come back to the code. Forget about these interfaces. We will come to all these things later. First of all, if you want to use stream, then you have to basically import this particular thing, java.util.stream.stream. Okay, everything else will be imported later, but this thing you have to import. Fine. So now let's get started. How to, first of all, we will see that there are two things. First is how I can create a stream from a collection type. Second is how I can create a stream not from a collection type in a general manner. Right? So two things: creation of stream from collection type, creation of stream in a general manner. After these two things are done, then we will see operations upon those created stream. And once we learn a few operations, and then we can proceed further. So another important point with respect to streams are that once you create a stream, you can use it only once. So I will show that example. But now let's start with the code. So let's say we have this list class object word list, and this is basically a linked list of these elements. Right? We are creating a linked list from, arrays.asList is used because I want to initialize the linked list inline along with the definition of the object itself. So I am initializing it. I am not using the add method. I am using it inline. So in order to inline initialization of linked list, we are using .arrays.asList function. We have this Moriarty, Lex Luthor, Dr. Octopus. So these are the villains, famous villains of comic book world. And then we have this, Moriarty is not comic book, if you consider Sherlock as a comic book character, but anyways. So word stream 1, we are converting it into stream. So this line is basically converting a collection type, which is basically a linked list in this example, into a stream. So what is the function? The function is the stream function. So stream function, collection.stream. Whatever is the name of the collection.stream. So this will convert it into a stream. And this stream we are catching into a variable of type stream of string. So this that's why I told you have to import that stream class. So stream class, now you have to mention what type of stream it is. So what is the data type which is, that stream is constituent of. So it is a string type stream, because these are, Moriarty, Lex Luthor, these are all string. A string of linked list, a linked list or string was there. From that I am converting it into a stream of string. Okay, now that is done. Accordingly, we can also convert an array. That was a linked list, this is an array. So here we have this array, but in case of an array, I do not have the dot string function. That is only there for collection type. Array is not a collection. That's why in order to convert an array into a stream, we use this stream of function. So stream.of, stream classes of function. and that will accept an array and convert it into a string of whatever the content was there inside array. So this will become, word string 2 will become a stream of strings, and those strings are price, woods, ghost, McTavish. If you are a fan of Call of Duty, you know these names. So, okay. So these are the two things. How we can generate strings from collection is by using the dot string method, and arrays we are using the stream.out method. Then, but what is this string? We will come to that. Just as of now, we have created it. Right? Then we will see that if it is not from collection or array or something else, but we want to create a stream of number, a stream of string, a stream of integer, whatever. Right? So how can we do that? So this, the method that used for that is generate. So you see, all these methods are for stream class. Stream.out, stream.generate. So all these are stream class methods. Okay, so we have this generate method. What this generate method does is, you mention a lambda inside the generate method. So once you mention the lambda inside the generate method, accordingly, generate method will call that function. Lambda is nothing but a function, right? So it will call that function multiple times and it will create the subsequent items in the stream. Okay, so it will generate the subsequent item. So one item, it calls the method inside it, the lambda inside it, and one return value it gets. That return value will be the first element in the stream. Then again it calls, then again return value gets. So accordingly, it will create a sequence by multiple times calling the same lambda function. Generate function, the generate function. Okay. By the way, so that I think one thing I forgot to mention, that is the name of the lecture was higher order function, the previous lecture. So why it is so? Because higher order functions are nothing but those functions which accept another function as an argument. So we have seen the enhancer function in the previous example, or generate function in this example in line 40. What are these functions doing? They are function in themselves along with that they are basically accepting another function as an argument, right? So a function which accepts another function as an argument is nothing but a higher order function. We call them higher order function. Okay, but anyway, so we have this generate method. In the first case, see, the lambda is nothing but a constant generation. That constant is a string constant, echo, but it is the constant echo word, right? So every time you write echo as it is used in the slide, the echo stream will nothing, it will be a stream of the word echo. So multiple time echo, it will be like this, a stream of the word echo. Okay, because the lambda is returning echo as the answer every time generate function is calling that lambda. Okay, and then again we have created another string, but this time we are using a bit more sophisticated function or lambda. Okay, now for ease of understanding, I have not used the lambda way of writing it. I have used the class way of writing it. Why? Because if you are still confused about how these things are working, you can see the definition of generate method. So see the generate method. You see in the generate method, this supplier, this extends T is there, TS is there, right? So what is this? Supplier class. So generate is nothing but, it is a function which accepts a supplier type of object, and that object is S. What is supplier? If you go to supplier, you will see that it is nothing but a functional interface. So you see, if I go to the definition, the functional interface, public interface, supplier T, and it will have one method which is get method. See, this is the definition of the functional interface supplier. It has only one method, the get method, T get. So this get method I have to overwrite. Okay. So therefore I am overriding the get method in the class. Okay, so you can see that. You can see, okay, whatever function I am using to send the lambda, either you can not worry about anything and simply pass a lambda like this. Right? You cannot worry, you don't want to worry about anything. Or if you want to understand how the thing is working, you can go to the generate method, hover over it, and it will show the function declaration. And here you see that it is actually accepting a supplier type object, then you can see what is supplier. And then you will see it is nothing but a functional interface and it has one method get. So that means if I want to pass a lambda in it, what I am essentially doing is I am overriding that method which is there inside that interface inside an anonymous class. And therefore I have defined it in such a manner so that it again helps you in understanding what's happening internally. But essentially I can do the same task here again. I can delete all this. right? You can send the yeah. So this is done. So see, this is the way we write lambda, right? We did the same thing again. Okay, so by the way, what is this function doing? So I am overriding it in such a manner that we are creating a random number, a random object generator, and then we are creating a random string. So what does this line does? So it is generating a random number between 1 to 15. So either the length, so this basically is the length value, which is basically randomly selecting a length. That length can be a unit length or it can be up to 15 unit of length. So 15 character long word or a single character long word it can be, right? So then whatever random size of the word I am getting at one of the iteration of this function call, then I will go through the length of the word and then I will again use random function to basically generate one of the character from capital A to capital Z. So this 65 is the ASCII code of a capital A, so it starts from 65, and since there are 26 characters in the range, so I am using 26 as the interval. So this r dot next int will generate an integer number between 65 to 65 plus 26, which is 91, right? So till 90. So 65 till 90 it will generate a integer, random integer, and that random integer is being converted into character, which is nothing but a ASCII code. That means this is nothing but a capital letter, right? Okay. So since this capital letter I have got, that I am adding with r string. So and how many times this will happen? This will happen a length time. So we will have a whatever the length is, that many letter long word. The only thing is this long word will be different in every iteration of the lambda call by generate method. So every time generate calls the lambda, the length will be different because the random file is, I mean, this random number generator is different. I'm sorry, not different. What I mean is this random number generator is generating random number at every instance. So sometimes the length will be 4, length will be 12, right? And accordingly this will run so many times. Okay, so then what we are doing is, so one generate method is accepting a particular lambda. This is again another way of passing, passing the argument inside generate method so that it understands how to generate the sequence of numbers. Right. So we can pass this math colon random. This will pass the random again also internally. It is also going as lambda method reference. So this will basically go to the math class. It will see that in math class there is a static method called random, and that static random method is creating some random integer value or double values, and it will basically take that value. So generate method multiple times it will call that random method, and basically it will get multiple values. Right. Likewise, for your ease of understanding how the first example is working, we have defined one of our own class. So we have this demo utility class, not class, an interface. Demo utility class only. Yeah. So we have demo utility class, and then in demo utility class we have this getTable method defined, right? And here we are simply generating, calling the getTable method so that it gets passed as a method reference, and every time this getTable is called by the generate method, we get a new random number, and that random number will be placed inside this string. Okay, fine. So likewise, we again have another string called alphas, and now we learn a new method called iterate. So generate was anyway accepting a lambda and creating your sequence of number by multiple times calling that lambda. But iterate, what it does is it gives you an initial condition just like for loop. So it will tell you from where do you want to start generating. Like here in this case I put the value to be A. The first argument is A, capital A. So that means I want to start generating from A. Okay. The next value is when the condition is following. So is A less than 90, less than equal to 90? Yeah. Capital A is 65, so therefore it is less than equal to 90. And the third one is how do you update it? So in the next iteration, what will iterate call through? Right? So generate was basically simply calling that lambda again and again without any change in parameter. But iterate can change the parameter, update the parameter, right? So and unless and until the condition is getting false and we are executing, just like for loop, right? Okay. So now what is happening over here is we are increasing the value of n by 1 every time. So basically we are going from A to Z because the value of Z is 90 in ASCII. So we are going from A to Z. Okay. Fine. So now what is happening? Okay, So now once we have converted everything into stream in different manner, either using iterate or using generate or using a collection or using array, whatever it is, but once we have made the things into in the form of a stream, therefore then next we can do what we can do is we can simply put these dots, right? So let's say the start long word stream is there. So word stream first thing is dot filter. See, it's very simple, it will happen. Otherwise you have to run a loop and check each element and you have to do stuff like that, right? But rather than that, what we are doing is dot filter w arrow w dot length, where length greater than 5. So that's what you are doing. So in order to, by doing this, you are ensuring that whichever word is there whose length is less than 5, I will not accept that. Okay, so where the length is greater than 5, only those particular elements will be passed on into the next part of the stream. So the syntax of writing it is using this kind of method, word stream dot, and now once you put the dot, that stream will be now operated upon by every subsequent function that you apply in it. So filter w arrow w dot length, right, greater than 5. Then map explode. What does filter do? As I told you, what map does, map is basically the transformation function. So it will take every item of the stream and it will do the function mentioned on the right hand side. So basically it will apply the explode method on each of the element inside the map, I mean the stream, right? So this is a stream of list of string, obviously, as you can understand. Okay, so then I am printing using the start, I mean using that object to call the for each method. Now for each method is what? For each is basically, again, it also operates on stream. What it does is it will go to each of the element and it will element in the stream, I mean, and it will basically print the element. When you basically for each whatever you do, so let's say for each you do some other lambda, right? So I greater I arrow I plus 5. So that means if you do a for each I arrow I plus 5, that means for every element in the stream it will be increased by 5. So likewise here I am not doing plus minus, what we are doing is simply printing the element. So each element is getting printed. Okay, fine. So all these things are already explained in the slide, so I will not go in quite some detail. I will request you guys to use this, check these functionalities on your own. There are many functionalities, but there is one thing that I want to discuss. Yeah, so this explode method that we just talked about, right? This this explode method. So what is this explode method doing? So explode method is not discussed, I mean sorry, not mentioned in the slide, but sir told you what it does. So it basically takes a string and separates it into its constituent characters and basically make a list of those characters and return it to the, I mean whoever is calling that, right? So basically we have defined that, just a second, we have defined that explode method over here, right? So please observe that at the end we have the explode method. So you can see a loop is running and returning the char value of the string, and we are basically storing that in a string and returning it. Simple thing, right? And then yeah. So what we are doing is map. What it will do, as I said, it will apply a transformation. So every object will be exploded. So every object will be broken down into its constituent characters, and then a list of characters will be generated after this map is finished its working. So at this point, what will the stream look like after the map has finished its work? So the stream will look like nothing but a stream of list of string objects, a stream of list of string objects, right? Because a list of the strings was generated by the explode method. Now it was already a stream, so therefore there is a stream, which stream is basically your this name, start long words, but the constituents of this stream is nothing but multiple object list. Multiple list created out of your characters of each of the word. Okay, fine, that is okay. Then see what this is all about is that map method. So once now that is being created, sorry. Oh, by the way, so let me just So again, what we do over here is we have this same till now filter and map. So filter and maps is still same. After that, we have this flat map. So what does this flat map does? Flat map, what it will do is it will take this lambda and it will apply it on each element of the previous string, just like map was doing. Then what it does is it will so basically, when are you applying flat map? You are applying flat map when your last condition of the string is a list. I mean, each object of the string, each element present inside the string is nothing but a list, right? So therefore, we have a multiple objects with not multiple. All of the objects are nothing but list. Now you want to break them and have a proper continuous string. So how can you do that? When you use the flat map method. So the flat map method, what it does is it accepts each element of the string as a list, right? So list arrow, list dot string. So what this line of code will do, it will convert it will accept the list handler will accept each of the let's say element in the string, and then that element is nothing but a list of characters, right? And that each of those list will be converted into list dot string. So again, a uniform string will be created if on all the object the list dot string is executed. And once a uniform string of object will be created where each element within the string is nothing but each character. Now the identity word has lost, only characters are present. Okay, inside the new string. So this is also done. Okay, so this is again similar kind of thing. I'm not going to the details. Same thing, same concept. Here a new concept is there, which is your optional type, right? So what is this optional all about? See, sometimes what happens is, we have seen this flat map example. Now what happens is, let's say I want to have a string by using generate map random function, then I want to limit it to 10. Limit means only 10 numbers will be considered, right? Limit the whole process to 10, only 10 numbers will be considered for the whole thing. So limit 10, filter it using a lambda, right? And then you call the max method to find the value which is maximum. Now this has also been discussed in the slide, because this might generate a null result, or it might also generate an exception if the value is not found. So in such a situation, we store it into a max rand variable of optional type. So basically any optional variable, so that because sometimes it might so happen that it is null. Then what does it mean? I mean basically you are storing a null value into a reference meaninglessly. So that's why in order to avoid such situation and make our code more useful later on, that we will see in the next week how this helps us, right? What we do is we basically check if the value is we got a proper value. If the value is not proper, then I will basically so let's say since this double time, if I get a non-double, if I get a null value, because the filter is not able to find any number, so the max is working on an empty set, so it will return a null value. So in such a situation, an exception will not be raised, but so we will store it into an optional type max rand, and then we can also operate upon it. We can say that if the value was a correct legal value, then you proceed and do this. If the value was not a legal value and null is returned, that means our conditions got failed. Then you return this value and accordingly we will proceed. Okay, so what is this return value? What is this? Accordingly we will proceed. We will understand that in the next week. But as of now, the idea is this thing, right? So please go to the lectures once again and also see the code walkthrough session once if possible again, so that it becomes more clear when you hear it for the second time. Okay. So as you can see, whether week 9 is starting, so we will see this in the upcoming week. So thank you all for your attention. I hope this helps you. Thank you.